David Spieth here with one more flipped classroom math video lesson. 3 tips before we start. First, you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to catch up with notes or write down some questions. Third, you can turn on the captions and read my words on the screen. Okay, let's do some problem solving with sets. So these are word problems that ask you to come up with numbers of elements in certain sets or subsets or intersections or unions and the like. So the situation for this problem is that we have a club where people play tennis and hockey, giving you abbreviations for those. And we're first going to need to populate our Venn diagram. Once we've got the numbers in there, then we'll shift over to the questions. So first off, there are 75 people in this club. So that's the universal set. We can write that there. And if you like, you could do something like that to indicate that there are 75 people in this universal set, which are club members in this particular club. We know 42 play tennis and 53 play hockey. So before we start getting into the numbers, let me just do my labeling. T for tennis, H for hockey. Now, these two numbers, 42 and 53, can I put those on the Venn diagram directly? Think about that. If your answer was no, you're right. 42 play tennis. That means the total of the tennis circle is 42. But there could be some in here and some in there. So 42 isn't going to go on directly. It's just going to be the sum of these two regions. And the same with the 53 who play hockey. 53 is going to be the total of whatever's in here plus whatever's in there. So we can't put these numbers directly on the Venn. So let's look a little further. 27 play both. So that is the intersection. The people in this group play both tennis and hockey. And guess what? We can put that right here. Because that's 27 play both tennis and hockey. So now we can work backwards and figure out what goes here, here, and there. So if 27 play both, and 53 play hockey, that's 26 left over for hockey but no tennis. Okay? Because 26 and 27 add up to this 53, so we know that's right. We have 53 people who play hockey, 27 of which play tennis as well. Okay? Pretty straightforward. Now we know that 42 play tennis. We've got 27 of them right here, so we have 15 more in there to make 42 for tennis. Okay? So we're almost there. We just need to check and see if there's a group that play neither tennis or hockey. And if we add these up, we're going to get 68, which means we're 7 short. So there's 7 people out there that don't play tennis and don't play hockey. So now that we have our Venn diagram populated with numbers, we can answer some questions. Okay, let's take a look at these questions. I've put them all in notation. So the first step here is to figure out what this notation is asking for, so you have sort of a qualitative view of what we're going to do with our Venn diagram. So let's do that. This stands for the number of elements in our universal set. This is pretty straightforward. This is total club members. And that was actually just given to us in the problem, and I do have it on my Venn diagram, so that's 75. These next two are pretty straightforward as well. This is the number of people in the club that play hockey. So that's going to be 26 plus 27. So this is play hockey. And that is 53. Because 26 plus 27 gives us 53. Now, how about this one? This is the number of elements in the intersection between T and H, between tennis and hockey. Pause the video and see if you can put that into just everyday words. This is the people that both play tennis and hockey, so this is play both. And now that's on our Venn diagram right there. That's the 27. That's the intersection of both these sets. So we have that. Now these last two get a little bit more complicated. This is the number of elements in the intersection between the people that don't play tennis and don't play hockey. Or to be even more abstract, this is the intersection of the complement of T and the complement of H. Remember, complements of sets are everything in the universal set that's not in that set. So this, T prime, complement of T, is everybody in the club that does not play tennis. And the same thing for hockey. So see if you can come up with words for that. How would we just simply describe that in words without complements and all that kind of stuff? This is play neither. Because this is T is all the people that, T prime is all the people that don't play tennis. So that's everything on the outside of the tennis circle, which would include some hockey people. But we're intersecting T prime with H prime, which is everybody that doesn't play hockey. So this intersection is everything that's not in either circle, which is our 7. So play neither is 7. Okay? Now take a look at this last one. What is this asking for? The number of elements in the union between T and H. So that's everybody. Well, before I say what that is, pause the video and see if you can come up with regular words to explain what this is asking for. This was a little tricky. This is play at least one sport. Okay, so it's the union of both sets. So that's this area, and that area. So these two are just play tennis or just play hockey. This is play both. So that's why I wrote play at least one sport, because that covers everything. So that's just going to be 15 plus 27 plus 26, which is 68. Okay? Now there's a little check. 68 plus 7 should give us the total in our universal set, and indeed it does. Now that you've watched the video, take a minute to jot down some notes, some questions, or a quick summary of the lesson. You can also re-watch portions of the video that were a little bit challenging the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.